Hey guys, Mr. Regan. Today we're going to do a little review on probability before the quiz here, so you can look at the problem, pause the video, do the problem on your own, then play the video and you can watch me do the problem. Hopefully we both get the same answers. Alright, first one. Using the spinner below, answer the following question. What is the probability of spinning a 5? Well, if I look at that spinner, there are 8 numbers on there, and one of them is a 5. So the probability of spinning a 5 is 1 out of 8. All right, how about spinning a 7 or 8 would be equally likely to? Well, let's see. I need to know the probability of spinning a 7 or 8 because equally likely means two events that have the same probability. So spinning a 7 or 8, there is one 7 and one 8 on there. That's two numbers out of 8 altogether, so that's a 1/4 probability. So I need to find something else that would be a 1/4 probability. Well, how about just picking two other numbers, like spinning a 2 or a 3? That would also be 2 out of 8, 1/4. So spinning a 7 or 8 would be equally likely to spinning a 2 or 3. Okay, I could have said 4 or 5, 4 or 6, any two numbers, because those two numbers would have given me that 2 out of 8, 1/4 probability, and that's what equally likely is, two things that have the same probability. Right, I rolled a number cube 20 times and recorded the results in the following table. What's the theoretical probability, so I'm going to be down here in red, of rolling a 2? Well, on a number cube there's 6 numbers, and there's 1 2, so 1/6. So for theoretical probability, I'm going to be looking at the number cube. Theoretical is what should happen. I have a probability of rolling a 5. Well, once again, there's 6 numbers on a number cube, and 1 5 on the number cube, so 1 out of 6. Rolling a 1 or a 2, well, that's two numbers out of the 6 on the number cube, so it's 2/6, which reduces to 1/3. And then probability of rolling an even number, well, a number cube has 3 even numbers out of 6, and 3 over 6 is 1/2. Remember, we always reduce to lowest terms. Right now we have experimental probability. Well, this I'm going to look at the table with results. So the probability of spinning or rolling a 2, well, a 2 happened once out of 20 times. Probability of rolling a 5 happened 10 times out of 20, which reduces to 1/2. A 1 or a 2, that's both of these, so that would be 3 out of 20. And then an even number, so we're looking at, that's an even number at 2, that's an even number at 4, and that's an even number at 6. So 1 0 and 4, that's 5/20ths, and that reduces to 1/4. Always lowest terms. Alright, the jar contains 12 red marbles and 8 green marbles. 25 students select a marble and replace it. Remember, that's important. Think about what the things are that are important. There's 12 red, there's 8 green, there's 25 altogether. We are replacing. The results are below. What is the experimental probability of choosing a green marble? So experimental means I look at the results from a table. So green happened 5 times out of, remember, 25. I simplify that to 1/5. Okay, experimental table. The jar contains 30 marbles, 6 are green. Suppose a green marble is drawn. On the first draw, not replaced. What is the probability of drawing a green marble on the second draw? And once again, important stuff. 30 marbles, 6 are green. That's going to mean that 24 are a different color. We're not replacing. Alright, so if I took a green marble the first time, that would be 6 out of 30, which is 1/5. Okay, but it says the second time. So if there were 6 out of 30, I don't replace it. Now there's only 5 green marbles, and there's only 29 altogether. So the probability of getting a green marble the second draw is 5/29ths. Okay, there's not 30, there's only 29, and there's not 6 anymore, there's only 5. All right, I have 14 blue pens and 11 red pens in a box. If I take out a blue pen and don't replace it, what is the probability of choosing a red pen next? Alright, so I got 14 blue, I have 11 red. I'm going to take out a blue, and I'm not replacing it. Okay, so now, if I take a blue out and don't replace it, I only have 13 blue. I still have 11 red. That gives me 24 altogether. So what is the probability of using a red pen next? I have 11 red, I have 24 altogether, 11/24. Alright, tree diagrams now. There are 3 green marbles and 5 yellow marbles in the jar. Draw a tree diagram to show picking 2 marbles with replacement. Then answer the probability questions. Alright, so we're going to label first pick. So we're going to do 2 picks. So my first pick, I'm either going to pick a green or a yellow. I have 3 green out of 8 altogether, so that's 3/8. I have 5 yellow out of 8 altogether, that's 5/8. If I pick green on my first pick, on my second pick, I could still pick a green or a yellow. If I pick yellow on my first pick, I could still pick a green or a yellow. Since I'm replacing, then my green is still going to be 3/8. So wherever I see green, 3/8. My yellow is still going to be 5/8. Wherever I see yellow, it's 5/8. That's going to be my second pick. Remember our labels. Right, then we have outcomes. So these are all the things that could happen, all the results. I could get green and green, could get green and yellow, could get yellow and green, or I could get yellow and yellow. Then we have our probability, and that's where we multiply the probabilities on the branches. So green, green, that's here, so it's these probabilities. 3/8 times 3/8 is 9/64. Green, yellow, 3/8 times 5/8, 15/64. Yellow, green, 5/8 times 3/8, 15/64. And yellow, yellow, 5/8 times 5/8, 25/64. These are all in lowest terms, so I can just leave them the way they are. All right, now, probability of green, green. There's green, green, 9/64. Probability of green, yellow. There's green, yellow, 15/64. Let's fix that up. All right, now, probability of at least one green. At least one green would be here, here, and here. So I would add these 3 fractions up. 9/64, 15/64, 15/64. That's 39/64. Also in lowest terms. And then exactly one yellow. Well, that's just going to be these 2. So I'll add those 2 probabilities up. 15/64 plus 15/64 is 30/64, which I can reduce to 15/32. All right, one more. Tree diagram without replacement. So it's the same problem. 3 green, 5 yellow, picking 2 marbles, no replacement. So let's start it off the same. They're always going to start the same. So we have a green or a yellow on our first pick. Green, there's 3 of them, so that's 3 out of 8, 3/8. Yellow, 5, 5/8. All right, then we have our second pick. My second pick, I could still pick a green or a yellow. Still pick a green or a yellow. Because even though I'm not replacing, I still have green and yellow marbles. All right, so if I picked a green first, and there were 3 out of 8 green, I now only have 2 green and 7 marbles, 2/7. If I picked the green first, then I still have 5 yellow, but I only have 7 marbles, 5/7. And don't forget, these 2 always have to add up to 1. Okay, when you're adding vertically the branches, they always add up to 1. All right, so here, if I pick the yellow first, I still have 3 green, but I only have 7 marbles. If I pick the yellow first, I don't have 5 yellows anymore, I only have 4, and I only have 7 marbles, 4 out of 7. I then need outcomes. These are going to be the same, green, 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 yellow, yellow, green, yellow, yellow. But my probability column is going to be different. So green, green is going to be my 3/8 times 2/7. And that's going to be, what, 656, which is reduced to 3/28. Green yellow will be 3/8 times 5/7. So that's going to be 1556. And yellow green is 5/8 times 3/7, 1556. And yellow is 5/8 times 4/7, and that'll be 2056, which reduces to 10/28. That's 10. All right, now probability of green green. There's green green right there, so that probability 3/28. Green yellow, that's right there, so that's that probability 1556. At least one green. There, there, and there. So add up those three probabilities. 656 plus 1556 plus 1556 is 3656. Lowest terms will be 18/28, and we can reduce that more, 9/14. Exactly one yellow will be just those two, so just those two probabilities. And that's going to be 1556 plus 1556 is 3056, which would reduce to 15/28. All right, there you go. That's all the stuff that's going to be on the quiz. Make sure that we understand the difference between theoretical and experimental probability, replacing, not replacing, how it's going to be different, whether it's independent or dependent. Make sure we understand what equally likely means, and then make sure we can draw tree diagrams with or without replacement. Good luck, guys.